Hello everyone, I'm Dr. Rhonda Kofel and I'm going to be doing a discussion about electrochemistry. If you're in my course, we're in chapter 19 of the TRO chemistry book, Atoms First. And so in this chapter we're going to look at oxidation reduction and how that occurs in a chemical reaction and the apparatus that you need to do that. And then we're going to interpret the energy changes of the cell. So in this part, what we're going to look at specifically is this first skill that you need to be able to do, which is balancing an oxidation reduction problem. And you may have done this in Chem 1. So if so, it's just a little review. So that's good. This will be easy for you. We use the half reaction method to do this. We're going to do the acidic version first, and then we're going to do the basic in a basic environment. Now, there are multiple methods to do this, and you can find them on the internet if you look. I use the half reaction method for the acidic solution, and then if it's in a basic solution, I just convert it at the end. So I do them exactly the same way every time. And then I just make that change at the end if it's in a base. And so when we get to that, I'll point that out to you. Okay, so what's an oxidation reduction reaction? Well, it's a two reactions together where you're transferring electrons from one atom to another. And we call it redox for short because oxidation reduction is a mouthful. And so if you lose electrons, you're being oxidized, and if you gain electrons, you're being reduced. And that's because you're reducing the overall charge because you're adding negatives. So that's why it's reduced. The easiest way to remember this that I found is to remember oil rig. You know what oil rigs look like out on the Gulf Coast, right? Okay, well, oil stands for oxidation is loss. Okay, oxidation is loss. And rig stands for reduction is gain. Okay, so reduction is gain of electrons, oxidation is loss of electrons. And if you'll just say oil rig in your head and remember what that stands for, every time you do this, you won't get confused. Now notice if you are losing electrons, they're going to appear as products because they came from here and went to here. If you are gaining electrons, then you're going to be adding electrons, and so they're on the reactant side. And so very simple. It's very simple when you look at it in these terms, okay? Oxidation can occur in lots of different ways. The oxidation number of an element could increase. It could lose electrons, it could add oxygen, or it could lose hydrogen, or it has electrons as products. Now, I'm all one for memorizing half of everything, right? So I remember whichever one of these makes sense to me. So oxidation, for example, and then I just remember that's oxidation. And if I have to answer a question about reduction, I just remember it's the opposite. So if you start trying to memorize, okay, then reduction is the oxidation number increases, it gains electrons, it loses oxygen, it gains hydrogen, and it has electrons in the reactants. So if you're memorizing all of those features for each thing, you're going to get them confused. So I just pick one, oxidation, for example, and I memorize that. And I know that this is what happens. Oil, okay, it loses electrons, therefore the electrons are on the product side, lottie, right? And then it adds oxygen, that's why it's oxidized, okay? It loses hydrogen because that's what happens when you're in water environment and you've got hydrogens and oxygens. So if you'll just remember this one, then just remember this one is the opposite. And that cuts in half the things you have to memorize. So a half reaction occurs because we have two things going on. We have an oxidation reaction where we're giving away electrons, and we have the reduction of something else where we're gaining electrons. And so in the in the example here, we've got 3 moles of chlorine plus iodide ion, and this could have been sodium iodide, it could have been potassium iodide. It doesn't matter. So if you see it written as NaI, that sodium is going to be what we call a spectator ion, and it'll be over here too, okay? So they cancel out, so we don't care about them. What we care about is anything that's not on both sides. So then we add water to it. We end up with producing 6 moles of chloride, 1 mole of iodate, and 6 moles of H+. And so they're showing you the oxidation numbers. I don't get all caught up in the oxidation numbers in here because you don't really need them to balance the equation, okay? So I know oxidation is loss, so I'm getting rid of 6 electrons. So where the I goes to whatever has an I in it on the other side, on the product side, and the chlorine goes to whatever has chlorine in it on the other side. And there's 2 electrons there and 6 electrons there. Now, that means that I may or may not have this balanced, okay? If not, then I'm going to have to figure some things out. And so balancing an oxidation reduction reaction is very complex unless you use the half reaction method, and then it's not so bad. So in this method, we break down the half reactions. The electrons go on the product side with oxidation and the reactant side with the reduction. And then we balance them for their atoms. And once we've balanced them for their atoms, then we are going to balance them for their electrons. That is, I'm going to need to have the same number of electrons in the reactants as I do in the products. So I've just put together this. This is the overall list of the rules in one slide for you. Some students like to print that out so they have it when they're working them. You assign oxidation states basically, and the main thing to remember on oxidation states is that an element has a 0 oxidation, all right, and an ion is equal to its charge. And since we're looking at metals mostly in these, that's what we go by. So if you know that, you're going to be pretty much covered. Then you write the oxidation reduction half reactions, including the electrons. Then you balance by mass, okay? So you balance by mass. And so you're going to balance the weirdos, I call them. So the actual metals that are involved, like chromium or magnesium or whatever you're using, okay? And then you are going to balance your hydrogen and your oxygen. You balance your oxygen by adding water, and you balance your hydrogens by adding H+. Okay? If it's done in a base, then I am going to, at the end, neutralize all my H pluses with OH minuses. And it's because it's in water I can do this, okay, because it all matches up. Then you balance the half reactions, okay. Balance the charges by adjusting the electrons, okay. So you make sure that your electrons are going to cancel on each side of the arrow. You add them together, and then you double check and make sure that your atoms and your charges are all balanced. Sounds so simple. Okay, so we're going to do a really easy one first. All right, so we don't have any oxygens in this, so that's what makes it easy. Once you see oxygens, that's when you have to start adding things to balance. So in this reaction, I have 2 half reactions, one involving aluminum and one involving copper. So I have aluminum solid that is going to aluminum 3+ aqueous. And then I have copper 2+ aqueous going to copper solid. Now, in order to figure out which one is oxidation and which one is reduction, I have to ask myself, okay, this is an element, so its charge, overall charge is 0. I have a 3+ charge over here. Okay, so they have to be the same, and I can only add electrons. So if it's 0 on the reactant side and it's +3 on the product side, I have to add 3 electrons, because then I have 3 negative plus 3 positives gives me an overall 0 charge. Then I look at the second one. I now know, since this one had product electrons, I now know they're going to be on the reactant side. How many do I need? I need 2. This is 0. This is a +2, so I need 2 electrons, so that I now have overall 0 charge on both sides. Okay, so now that I've got that done and I know how many electrons I have, I'm going to have to balance these so that when I combine them, the electrons will cancel. So how do I do that? You know, anytime you have a 2 and a 3, you're going to multiply them. Okay, so what that means is if I have 3 electrons up here, I'm going to multiply this whole thing by 2. And if I have 2 electrons down here, I'm going to multiply this whole thing by 3. So when I do that, I'm going to rewrite it so I don't get confused. So I'm going to write all the reactants over here first. So 2 times 1 aluminum is 2 aluminum solids plus 6 electrons. 3 times 2 is 6, plus 3 copper 2 plus gives me 2 Al3 plus 6 electrons, right? 2 times 3 plus 3 copper. So what I did was I had 3 electrons here and 2 here. I had already balanced my aluminums and my coppers, the weirdos, okay? So they were already good. And so, but in order for me to have 6 electrons on each side of this, I had to do what? I had to multiply the top one by 2 and the bottom one by 3. And what I do to one thing, I have to do to all things. So my balanced redox equation, equation for this is ALS plus 3Cu2 plus gives me 2Al3 plus 3Cu solid. So I made sure first that the aluminums and the coppers were balanced. Then I figured out where the electrons went. Then I figured out what I'd have to multiply each one by in order for them to have the same number of electrons on each side. Then I combined the reactants and the products. I canceled out my 6 electrons on both sides. And then this is what I had left over. And so that is the balanced chemical equation for Al solid plus Cu2 plus. Notice I'm telling you they're in acidic solutions, okay, because that's important for you to remember when we get to the difference between the two. All right, so this is for more practice, but since it's complex, I'm going to go ahead and I'm going to write it for you. Okay, I'm going to go through the steps with you because this is one where you actually do have your oxygens and all that. Okay, so dichromate, and if you don't know what dichromate is, you do have a polyatomic chart, okay, that you can look that up. But it's easy to remember dichromate because dichromate has 2 chromiums. So it's Cr2O7 2 minus. Okay, and it could have been sodium dichromate, potassium dichromate. We don't care because that doesn't get involved in the redox reaction. Then I'm going to add that to iron 2. Okay, iron 2 ions. And then that's going to form chromium 3 ion. All right, and iron 3. Okay, so it's telling me that. Remember, Roman numerals tell me what the charge is. Okay, so these are just the ions again. I don't have to worry about sodiums or anything like that because they're all going to go away anyway. In this one, though, I do have some oxygens, and so that's why I'm showing you how to go through this one, because you're going to have to first balance the weirdos. Okay, so I've got 1 iron on both sides. I've got 2 chromiums on the left, and so I need 2 chromiums on the right. Okay, now, and this is before I do electrons, okay, before I do electrons. All right, I'm going to go ahead and do them in their half reactions. So I've got Cr2O7 2 minus, and it's going to go to 2Cr3 plus. And I'm going to have Fe2 plus go to Fe3 plus. And that's pretty easy because iron is, there's just 1 iron, right? So I'll only have to do electrons on it. So which side has electrons? Well, you got a +2 on this side and a +3 on that side, and I can only use electrons to balance. So I'd have to have 1 electron on that side. And now the overall charge on the right is a +2, and the overall charge on the left is a +2. But the dichromate one's going to be a little more involved because, all right, I balanced my chromiums, right? I have to do this before I do the electrons, okay? Before I do the electrons. So I'm balanced with chromiums, but I'm not balanced with oxygens. When I balance an oxygen, I do it with water. So I have to add, how many oxygens do I need on that right side? 7, right? So I've got to add 7 waters. And that gives me 7 oxygens and 7 oxygens. But now, since I had to add water, I have hydrogens. And so I'm going to have to balance the hydrogens I added by adding 14 hydrogens on the left side, because 7 times 2 is 14. All right, go back through it. Chromiums were balanced. I have 7 oxygens. I have to balance oxygen with waters, and I have to balance hydrogens with H pluses. Okay, so since now I have 7 and 7, but now I have some hydrogens over here that I have to balance, so I had to add 14 H pluses on the left hand side. Now I've got all of that stuff balanced. Now I can figure out how many electrons. Okay, so I'm looking at the overall charge. So I've got a -2 and plus what? 14. So I've got a +12 on that side, because 12 minus 2 is 12. 14 minus 2 is 12. Okay, water is 0. Okay, water is 0 because it's a liquid, right? So I have 6 pluses on this side. I can only balance with electrons. So if I've got a +6 on this side and a +12 on that side, I've got to add 6 electrons to my reactants. So now I have 8, right? So now I have 8, because they don't have to be 0, they just have to be the same. So now I've got 8 negatives and 14 positives, and then now that gives me +6. So I've got +6 on both sides. So they don't have to be 0, they just have to be the same. Okay, just like this one is +2 and +2. All right, so now I've done that. So now what I have to do, I balance, so all my mass things are balanced. So now what I have to balance are my electrons. And so in order to do that, I'm going to multiply both of these. This one has 1 electron. This one has 6. That's multiplied by 1 basically because it's already going to be okay. And I have to multiply this one though by 6. So I can have 6 electrons here and 6 electrons here. All right. So now that I've done that, I'm going to go in and very carefully rewrite my reactants on one side and my products on the other side. All right. So I have 6 electrons. So I'm starting with this one, of course, plus Cr2O7 2 minus plus 14H plus. All right. So that's it for the top one. Plus 6 Fe2 plus, and that's going to give me 2 Cr3 plus 7 H2Os plus 6 Fe3 plus 6 electrons. Did I get everything? Okay. All right. So I now have 6 electrons on both sides. So anything on both sides of the arrow cancel. And so I marked those electrons out. And so my final step, I have Cr2O7 2 minus plus 14H plus 6 Fe2 plus give me 2 Cr3 plus 7 H2O plus 6 Fe3 plus. So that first one we did, that really simple one, you might have been saying, well, I could have done that in my head, right? Yeah, and you might could have done the iron one in your head. But it gets complicated when you have oxygens involved. And sometimes you're going to have oxygens in more than one of these. And then it really gets, a little hairy. So you've got to watch what you're doing. You've got to be super careful, and then always go back when you get to this point and check and make sure you've got 2 chromiums and 2 chromiums and 14 H's and 14 H's and 7 O's and 7 O's and 6 irons and 6 irons to make sure that you did balance it correctly, because sometimes you'll get off on one thing. And especially like at this step right here, when you're doing the multiplication of the two, sometimes you miss one or you don't put the right number by it or something. So you've got to be extremely careful when you do these. So as I said, that we've been doing those in an acidic environment. What makes it an acidic environment? Well, it has free hydrogens, right? That's what makes it an acid. And so in this, when we get it balanced, we have free hydrogens in our balanced chemical equation. But if you're in a base, you can't have free H pluses because that would be an acid. You're going to have OH minuses. That's what makes it a base, right? Because you have H pluses in acids and OHs in OH minuses, and that makes your water. Okay, so when you're in a basic solution, okay, I do it exactly the same way that I just did it, okay, but at the very end, I just swap out my H pluses for my OH minuses. And that way you only have to learn to do it one way, and then there's just one little extra step at the end for your base. And to me, that's the easiest way. Now, if you go look at Khan Academy or somebody like that, you're going to see them balance it in a base. And when they balance it in a base, to me, it just confuses me. I get so confused when I start putting those OHs in there early and all that. So I just do it as an acid, and let me show you what I'm talking about. All right, and then you can go and look at that other one if you want to, but don't ask me how to do it because I don't do it that way. and I'm not saying my way's better, but usually I try to find the easiest way to do it, and where you only have to memorize, you know, the minimum of things. Okay? All right. So here is my equation. I'm balancing it just like I always do, except I'm going to look at this because I know that whether it's acid or base is going to impact my final equation. All right. So I'm going to have two half reactions. So I've got I minus going to I2. And both of those are aqueous. And then I have the hard one, MnO4 minus, that's permanganate, going to manganese dioxide, which is a solid. All right, so I have, this is a 0, right? This is a 0, and this is a -1. And so if they both sides need to be a -1, then I'm going to have to do what? I'm going to have to add an electron, right? Is that right or not? Well, I don't know yet. Okay, I don't know yet because I'm going to go ahead and erase that. All right, and the reason I ask you to kind of think about this is because these have oxygens. I cannot know what the electrons are going to do until I get done. This first one, though, it doesn't have any oxygens, and so I know what's going to happen to it. What's going to happen to this one? I have, first of all, I got to balance my iodines. So I have 2 on that side, so I have 2 on the other side. So I have a 2 negatives over there, right? So that's going to be plus 2 electrons. Now notice if I was just doing -1 and a 0 and put plus minus 1 over here, I'd have electrons both on the same side, and that can't happen. So you're going to do your one without your oxygens first. Okay. All right, so now I know my electrons are going to go on the left-hand side, but I don't know how many. So my manganeses are balanced. Okay, so I've got to balance my oxygens. Notice that I have 4 oxygens on this side and 2 oxygens on that side. So how many oxygens do I need on the right-hand side? 4 minus 2 is 2. So I only need 2 waters over here. So now I have 4, 2 plus 2, and 4 on the other side. So my oxygens are balanced. But I did what? I added hydrogens, and so I've got 4 hydrogens now over here, so I have to add 4 H pluses to this side. You could always go back and reverse me if you need to repeat any of these steps, okay? Because this one had oxygens on both sides. You only needed 2 because you have 4 over there and you already had 2. Okay, so now everything is balanced. I've got to look and see. All right, this is a 0 and that is a 0. So it's 0 on the right hand side, and it's 4 plus and minus 1 on this side, so it's plus 3 on this side. I can only balance with electrons, so I'm going to add 3 electrons. When I add 3 electrons, I now have 4 minuses and 4 pluses, and that's 0. So now both sides are balanced. Now what's the next step? Everything's balanced but what? The electrons. Okay, so I have 2 electrons here and 3 electrons here, so that's the 2 times 3 rule. So I'm going to multiply the top one by 3 and the bottom one by 2. And then I'm going to rewrite it. So for my iodine, 2 times 3 is 6 I minus. Let's see, 6 I minus plus 2 MnO4 minus plus what? I got 4H2O. I'm going to go ahead and do all of this, okay? So I had 4 H pluses. So now I have 8 H pluses plus 6 electrons, right? Is that everything? 6 iodines, 2 MnO4s, 8 H pluses, and 6 electrons. And that goes to 2 MnO2s. Wait, be consistent, sorry. 3 I2s plus 6 electrons plus 2 MnO2s plus 4 waters. All right, so my electrons cancel. All right, so I'm going to rewrite 6 just to make it a little neater, plus 2 MnO4 minus plus 8 H plus to 3 I2s plus 2 MnO2 plus 4 H2Os. I just rewrote it without the electrons in it since they already balanced. All right, so I need to get rid of the H pluses, right? Because I can't have H pluses. So if I have 8 H pluses over here, right, and I need to instead of H pluses, I need to have OH minuses, right? OH minuses. So what I'm going to do is I'm going to say, okay, I've got H pluses over here, so I need, and I've got 8 H's over here, I need OH's. So how would you do it? Think about it for a minute. You can always use water, right? You can always use water. So I want to add OH's. I want to add OH's. So to get rid of this, I'm going to add on this side 8 OH minuses. 8 OH minuses. On this side, that takes care of that, right? But if I have 8 OH's over here and I add 8 OH's over here, what does that make? 8 waters. So I added the 8 OH's on the right hand side to cancel out my H pluses, to cancel out my acid on that side. But if I add it to this side, I add it to this side, I'm getting rid of my H plus, and now I have 8 H2Os. I have 4 H2Os over here. Okay, so this turns into that. So what I now have is 6 I minus plus 2 MnO4 minus plus what? I've got 4 waters on this side and 8 waters on that side. So these 4 will cancel, and it cancels out 4 of those waters and leaves me with 4 waters on this side. 3 I2s plus 2MnO2 plus 8OH minus. Now, you see what I did and you see how I did it, right? But in reality, all I did was if I had, I'm gonna erase this just a little bit so I can see what I'm doing. All right. When I was adding these OHs over here, what I did was, okay, I took my 4 H2Os from this side and moved it over here, and I took my 8 H pluses and I moved them over there and made OHs. So if you're okay with not internally knowing how you're doing it, you just move your water to the opposite side and replace your H plus with your hydroxide on the product. That's all I did. I swapped H plus for OH, the same number and everything, right? And then I moved my waters on the opposite side. Okay, so I showed you why, because I'm adding OHs to both sides, made 8 waters, add 8 OHs over here. I had 4 waters over there, so if I take 4 waters away from both sides, you get it there. But it works like that every time. So you have now done it, and I did that because it's in a what? Base. You can't have free H pluses in a base. All right, if you need to go back and look at that a little bit, it's quite all right, okay? And then I have you one to practice. All right, and that's it for balancing redox reactions in an acid or a base.